In this lecture, I am going to discuss about the multiplication property of the Fourier transform. To understand this discussion clearly, you have to write, you have to remember uh, following conversion formula. First, the Fourier transform of any signal xt, which will be a function of omega, and you can write the Fourier transform of any signal xt equal to minus infinity to plus infinity xt e to the power minus j omega t dt. And second thing which you will have to remember is inverse of the Fourier transform, that is xt. Xt is the inverse of the Fourier transform x omega, which will be equal to 1 by 2 pi integration minus infinity to plus infinity and x omega e to the power j omega t d omega. Fourier transform of any signal which will be in time domain, convert the signal in frequency domain, and Fourier inverse will convert the signal from frequency domain to time domain. So this is difference between Fourier transform and inverse of Fourier transform. And third thing you must remember is frequency shifting property. Frequency shifting property is if Fourier transform of any signal xt is x omega, then its transform will be shifted if you multiply term e to the power j omega t, omega naught t in xt. If Fourier transform of any signal xt, then Fourier transform of e to the power j omega naught t xt will shift the transform by an amount omega 0 in right direction. So this property is called frequency shifting property. And the fourth thing which you will have to remember, the convolution. x1t convolution x2t, which I have discussed in the previous lecture in unit 2 of your course, it will be equal to minus infinity to plus infinity x1 tau and x2 t minus tau d tau. So all of these formula I have discussed earlier. I have discussed all of these formula. So you must go through that formula, that conversion formula, for the better understanding of this property. Now, what is multiplication property? According to this property, if Fourier transform of any signal x1t is x1 omega and Fourier transform of other signal x2t is x2 omega, then according to this property, you can find the Fourier transform of their product. It means the Fourier transform of the product of these two signal x1t and x2t will be equal to 1 by 2 pi of x1 omega convolution x2 omega, x1 omega convolution x2 omega. So by using this property, you can determine the Fourier transform of the product of two signals. So now I'm going to prove this statement. As you know, the Fourier transform of any signal xt will be equal to xt to the power minus j omega t dt. If you want to determine Fourier transform of yt, then in place of xt you will have to write yt. If you want to determine Fourier transform of x1t into x2t, then in place of xt you will have write to x1t into x2t. So what will be the Fourier transform of x1t into x2t? So in place of xt, you will have to write x1t into x2t and then e to the power minus j omega t dt. This will be the Fourier transform of the product of the signal x1t and x2t. Now what is x1t? x1t is the Fourier inverse. x1t is the Fourier inverse of x1 omega. Fourier inverse of x1 omega. And Fourier inverse of x1 omega, you can see here, the Fourier inverse of any signal which is in frequency domain will be equal to 1 by 2 pi integration of minus infinity to plus infinity x omega e to the power j omega t d omega. So if you want to determine Fourier inverse of x1 omega, which is x1t, and this will be equal to, according to definition of the Fourier inverse, this will be equal to 1 by 2 pi minus infinity to plus infinity x1 omega into e to the power j omega t into d omega. Or in place of omega, you can write theta. So in place of this omega, you will have to write theta. In place of this omega, you will have to write theta. So in terms of theta, you can write this will be equal to 1 by 2 pi minus infinity to plus infinity. In place of omega, you can write theta, x1 theta e to the power j theta t. In place of j omega t, you will have to write j theta t. And in place of d omega, you will have write to d theta. This is the property of integration. You can replace the term. So basically 1 by 2 pi minus infinity to plus infinity x1 theta e to the power j theta d theta is the x1t. So in place of x1t, you can write this. This is x1t. You can see here x1 theta e to the power j theta t d theta. x1 theta e to the power j theta t d theta. This is x1t. This is x1t. And then you will have to write x2t. So x2t is here. Then e to the power minus j omega t, e to the power minus j omega t here, and then dt. Now you can readjust the term which are existing inside the integration. So you can get this expression, this complete expression, just by readjusting the terms which are existing in the integral. So now come to this expression. What is this? What is this? This is basically the Fourier transform of e to the power j theta t x2t. This is Fourier transform of e to the power j theta t x2t. And as you know, from the frequency shifting property, if Fourier transform of xt is x omega, then if you will multiply e to the power j omega naught t in signal xt, then in frequency domain, signal will be shifted in right direction. If you will multiply j theta t, then signal will be shifted by an amount theta in right direction. So if in this expression you can see e to the power j theta t is multiplied with the signal x to t. So the Fourier transform of x to t is x to omega. Then what will be the Fourier transform of e to the power j theta t into x to t? The Fourier transform will be shifted in right direction by an amount theta. So this is the Fourier transform of x2 t e to the power j theta t, and from the frequency shifting property it will be equal to x2 omega minus theta. So this is from the Fourier transform of frequency shifting property of the Fourier transform. This is existing due to frequency shifting property. Now you know from the convolution of x1 omega and x2 omega will be x1 tau, x2 omega minus tau d tau, or you can write x1 theta, x2 omega minus theta d theta. So this integral is just a convolution between x1 omega and x2 omega. So in this way you can prove the multiplication property of the Fourier transform. So this is the multiplication property of the Fourier transform. So you must remember this property, and with the use of this property, you can determine the Fourier transform of product of the two signal. If the Fourier transform of x1t and x2t are known, then you can easily determine Fourier transform of its product by using this property. Now I am going to discuss one more numerical example. Here, if Fourier transform of xt is x omega, then find the Fourier transform of txt. What will happen if you will multiply t in the signal? Then what will happen? In this expression, in this problem, it is given the Fourier transform of xt is x omega. Then what will be the Fourier transform of txt? So you can easily determine the Fourier transform of txt, because you know the Fourier transform of any signal xt will be equal to x omega, and x omega will be from minus infinity to plus infinity xt e to the power minus j omega t dt. This is the Fourier transform of any signal xt. The main role of Fourier transform is to convert time domain signal into frequency domain signal. So x omega will be minus infinity to plus infinity and xt e to the power minus j omega t dt. This is the Fourier transform of any signal xt. Now what will happen if you will differentiate x omega with respect to omega? Then what will happen if you will integrate this expression with respect to omega? Then xt will be constant because you are integrating with respect to omega, and sorry, if you are differentiating with respect to omega. So what will be the differentiation of this term with respect to omega? This will be equal to minus jt and e to the power minus j omega t dt. And when you will multiply both sides by the term j, then in left hand side it will be j d x omega by d omega, and in right hand side it will be minus infinity 2 plus infinity, and j into j will be j square, which is minus 1, and minus 1 and this minus results in plus sign here, and the remaining term will be t xt e to the power minus j omega t dt. Now see this expression. What is this? You can see here in place of xt, the term is txt and e to the power minus j omega t dt. So, as you know, the Fourier transform of any signal xt is xt into e to the power minus j omega t. If you want to determine Fourier transform of txt, then what term will exist here? Here the term will be txt. So you can see here the term txt is existing in place of xt. So you can say this is a Fourier transform of txt. So in this way, you can determine the Fourier transform of txt, which will be equal to j into differentiation of x omega with respect to omega. So in this way, you can solve this problem. If Fourier transform is given, any signal is given, then you can determine the Fourier transform of t times of that signal. Similarly, you can determine the Fourier transform of t squared times of that signal. How you will determine the Fourier transform of t square xt? Just you have to differentiate this expression once again with respect to d omega. You will get the Fourier transform of t square xt. So in this way, you can determine the Fourier transform of any signal which is multiplied with the t or t square or tq. And in next lecture, I will discuss some more properties of the Fourier transform.